In the distant reaches of our solar system, beyond the orbits of Mars, Jupiter, and Saturn, lies a mysterious, icy giant known as Neptune. For centuries, this deep blue world remained shrouded in mystery, veiled by its extreme distance and the challenges of long-range observation. But now, in a stunning turn of events, the James Webb Space Telescope, humanity's most powerful eye in the cosmos, has captured a discovery that has shaken the very foundations of planetary science. Recent data received from the Webb telescope has revealed an extraordinary anomaly in Neptune's atmosphere. Something enormous, a celestial object of considerable mass, appears to have collided with the gas giant. The evidence is not a matter of speculation. It comes in the form of a sudden spike in infrared radiation, atmospheric disruptions, unexpected temperature gradients, and unusual cloud formations that had never been observed before. When first detected, scientists were skeptical. Could this truly be the result of a collision? Was this some sort of internal weather event? But as the data poured in from Webb's ultra-sensitive instruments, the picture became undeniable. Neptune had been struck. The implications are profound. The object, estimated to be tens of kilometers wide, may have originated in the Kuiper Belt, a vast region of icy bodies and remnants from the early solar system that lies beyond Neptune's orbit. The rogue body, possibly an ancient asteroid or even a minor dwarf planet, had been drifting silently for millions of years before it was pulled into Neptune's gravitational well. Its impact was immense. Simulations suggest the energy released upon collision was equivalent to millions of nuclear detonations. This caused an immediate thermal spike in Neptune's upper atmosphere, triggering cascading waves of turbulence. Methane clouds, normally swirling slowly under the grip of supersonic winds, were suddenly torn into chaos. Bright thermal hotspots emerged in places that had been calm for decades. Neptune, which had once seemed distant and inert, was suddenly a theater of violent change. Spectroscopic data confirmed the release of compounds that had never before been detected in Neptune's upper layers. Gases from the planet's deeper atmosphere had been ejected upward, exposing materials that are usually hidden beneath miles of pressurized clouds. It was as though the planet had briefly opened itself up to human eyes, revealing secrets that had been buried since the birth of the solar system. This event has forced scientists to reevaluate long-held assumptions about the outer solar system. For decades, the region beyond Jupiter was thought to be relatively stable, a cold storage of ancient objects, frozen in time. But this collision suggests otherwise. The Kuiper Belt, it seems, is not a quiet graveyard of rocks and ice. It is an active, dynamic region still capable of sending enormous objects inward. And if such a large object can collide with Neptune, what does that mean for other planets? Could Uranus be next? Could one of these bodies veer closer to the inner solar system, perhaps even Earth? Planetary defense experts have begun re-examining their models in light of this new data. The notion that we are safe simply because of distance has now been challenged. Some researchers believe this incident may be linked to broader gravitational patterns. For years, astronomers have theorized the existence of a ninth planet, an as yet undetected massive body that could be influencing the orbits of distant objects. This mysterious Planet 9, if it exists, may be perturbing Kuiper Belt objects and nudging them into dangerous trajectories. Alternatively, the gravitational influence of passing stars, rare but not impossible, could occasionally stir up the outer solar system like a spoon in a cosmic soup. Meanwhile, artificial intelligence systems have been employed to comb through years of astronomical data, searching for any precedent. So far, nothing quite like this has been observed. Smaller impacts have been seen on Jupiter, such as the famous Shoemaker-Levy 9 collision in 1994, but Neptune, due to its distance and visual obscurity, has never offered such a clear spectacle. As scientists continue to monitor Neptune's evolving state, they are also watching the skies. Could there be other objects following a similar trajectory? Are we witnessing the beginning of a new phase in solar system dynamics, or was this a rare and isolated event? These questions remain unanswered, but the urgency to answer them has never been greater. The James Webb Space Telescope has opened a new window on reality. What it has shown us is not a peaceful, quiet solar system, but a universe full of motion, mystery, and unexpected violence. Neptune, once a symbol of serene distance, has become a focal point, a reminder that no corner of the cosmos is truly beyond reach, and no world is safe from the random whims of space. The story is still being written. But one thing is certain: the outer solar system is awake. And it has our full attention. In the weeks following the unprecedented impact on Neptune, the scientific community has been propelled into a frenzy of activity. What was once an event relegated to headlines and late-night broadcasts has now evolved into a central focus of planetary science, astronomy, and even geopolitics. The echoes of the Neptune collision continue to ripple through the solar system, and through the minds of those who seek to understand what it means. The James Webb Space Telescope, still pointed firmly toward Neptune, has recorded subtle but alarming patterns emerging in the gas giant's atmosphere. Long filamentary cloud structures have begun forming around the equator, spiraling in patterns that defy the known models of gas giant behavior. These formations appear to follow no discernible weather pattern and have led to speculation that the internal dynamics of Neptune may have shifted entirely. Meanwhile, the magnetic field of Neptune has grown erratic. Previously known for its strange, off-kilter tilt, the planet's magnetosphere is now fluctuating wildly, with bursts of charged particles being ejected into space at intervals. These auroral flares are visible in both the ultraviolet and infrared spectrum, a display unlike anything ever witnessed on a planet so far from the Sun. Even more bizarrely, Voyager 2, now over 130 astronomical units from Earth, has picked up low-frequency radio signals apparently emanating from the direction of Neptune. These emissions are rhythmic, pulsing at intervals that form a rough harmonic progression. Initially dismissed as natural background noise, closer analysis by AI-enhanced signal processors suggests these patterns may be the result of oscillations triggered by the impact, or, more speculatively, some previously unknown interaction between Neptune's magnetic field and the object that struck it. The origin of the impacting object has become a topic of global debate. Astronomers across the world have intensified their Kuiper belt surveys. New objects have been identified on erratic, elliptical orbits, several of which appear to have gravitational anomalies. These findings lend credence to the Planet 9 hypothesis, which posits the existence of a massive, unseen planet far beyond Neptune. Could this object, or something like